Hi, 8th graders. I hope you guys had a great spring break. I am back with a brand new fantastic video for you to help you learn a little bit about waves. I thought this meme was quite funny. Maybe if somebody can tell me why it's funny, shoot me an email or shoot me a text through Mind, and maybe I'll give you some extra credit. Look it up. All right, so today, since I only have a few minutes, 15 minutes approximately with these videos, I'm going to spend some time going over the anatomy of a wave. Before spring break, we looked at the three major types of waves, or I'm sorry, two major types of waves, electromagnetic and mechanical waves. So let's now get into the anatomy, and that's your goal this week, is to kind of understand all the different parts. All right, so here we go. Before we start, let's do some review. Why not? So just remember, so I want to kind of point back out, a wave is a disturbance that transfers energy from place to place. So that key word is energy. And then here is an example of an electromagnetic wave. And if you remember, one side is electric and one side is magnetic. And one thing I did point out last time is that I did mention this is a transverse wave, which we're going to talk a little bit about that today and what is a transverse wave. But these are two transverse waves that are perpendicular to each other. So this one's kind of like, if you were to imagine it kind of being sideways, and then this one's kind of going in the other direction. Um, so these are the ones you would see kind of floating through from the sun to Earth, right? Light waves is what they would look like. All right. So there are two types of waves that you need to know: an electromagnetic wave and then a mechanical wave. And most waves can be categorized under these particular types of waves. Uh, there are some other special exceptions, but the ones you need to know for 8th grade are these two types of waves. Okay, so I gave you guys a quiz, and most of you guys did really well on it. There was one question that I wanted to kind of go over that was the most missed question. So which of the following describes how a mechanical wave is different from an electromagnetic wave, right? So the biggest difference is that mechanical waves can only travel through matter or a medium, right? So mechanical waves, an example would be like sound is a mechanical wave. It can travel through matter. It has to travel through matter. It has to have a medium of some sort. Whereas an electromagnetic wave, which is an example would be like light, it does not need matter, okay? It does not need a medium to travel. So those are the two big examples that you really need to know, kind of going into the end of this year for this unit. All right, so did you know that bats actually use mechanical waves? They use sound waves. So we're going to talk about sound being a type of mechanical waves to find their dinner. All right, so it uses these what's called echo locations, and they travel out and then bounce back off the prey, and that's how the bat knows how to reach its dinner. So again, make sure you understand that sound waves, which are a type of mechanical wave, can travel through a medium or some sort of gas, a medium of gases. So that's what's happening in this situation. But a medium could be also a solid or a liquid. Those are just states of matter. Okay, so here's what we know so far. So we're going to be adding to this. And as I go through this PowerPoint, and today I think I just had I said, go ahead and just watch these videos. But it's a good habit to take some notes. Um, and more likely, I'm gonna let you use your notes, on the tests and things like that, because, why not, right? But if you're doing the work, um, it actually helps you. It helps you, and I think I've said this many times in class. Writing stuff down actually helps you retain it more. So just kind of looking at it, listening is great, but if you write some stuff down that you think is important, I think that's helpful as well. So here's what we know so far. I kind of broke this down into like a little graphic organizer. And you guys did a Venn diagram. If you did it, thank you. Which has a lot of the same information, all right? So we got waves at the top, and they can be broken down to two categories: EM waves and mechanical waves. Does not need a medium, needs a medium. And then EM waves are going to be only transverse waves, and we're going to talk more about that today. And the mechanical waves can be transverse waves, but they can also be longitudinal waves. Kind of a funny word, but longitudinal. So let's look at that. Okay, so we're going to look specifically at transverse waves. So transverse waves, they could be an EM wave or they can be mechanical. And there are, so you got to know the different parts of a wave. So they're going to kind of look like this. They're going to have kinds of like roller coaster kind of going up and down. Notice they're all at the same height for the most part, right? Uh, and there are two parts to a transverse wave. There's the crest, which is the topmost part right here, and then the trough, which is the lowest point, okay? I always think of like if you're at a farm maybe, or if you have maybe a relative owns a farm and they have what's called troughs, right, for feeding, I don't know, pigs, things like that. It has this kind of bowl shape to it, right? At the lowest point, that's what we call a trough, if that helps you kind of memorize it. And then the crest, if you think maybe like the crest of a wave, that's like the topmost part. If you like surf, you kind of want to, you're looking for those crests and things like that, or the different parts of the wave. You can tell I don't do a lot of surfing because I don't know exactly what you look for, but there it is, right? The crest would be the top of that wave. Okay. And then you have, so in a transverse wave, okay, the particles of the medium move at right angles. So here's a transverse wave and it's moving. Propagating is what they would call it, right? They call it propagating, but it's moving in this kind of direction from left to right. And that's why I put an arrow to put this, kind of show you which way the wave is moving. And it could be any type of wave, it could be a light wave, maybe moving through space. And these kind of little circles are particles. Those could be anything. They could be, they could be uh, dust. It could be other matter like oxygen. It could be a lot of different things. But if you notice here, remember, wave is energy, is a way of transferring energy from one place to another, not necessarily moving the particles themselves. Uh, they move, but they're not necessarily moving from left to right, right? So this, if you followed one of these particles, it would not end up all the way on the right side, but where it is moving is kind of up and down, and that's really what a transverse wave does. The particles of the medium move at right angles to the direction of the wave motion. So if the wave motion is this way, the particles are going to move right angles or up and down. So that's kind of what a transverse wave does. So we can see this, and you can play along with it. You can play in this. This is a PhET simulation, and I put the link, and you can pull up the PowerPoint and go in here. So look at which way the wave. So if I turn on oscillate, you're going to see this is just kind of a representation of what a transverse wave might look like, and you can see which way the wave is traveling. It's traveling from here to eventually to here. Okay, but which way are the particles in the medium moving? If you look at the green orbs, that's why they put them there. The green orbs aren't necessarily moving. This green orb doesn't end up all the way over here. It's just moving up and down. So that's very important to understand. Even though energy is moving from left to right, the matter is not necessarily moving. It's just moving at a perpendicular to the motion of the energy. So it's moving at right angles with a transverse wave. And you can play around with this, and I would encourage you to do so. So now flipping to a longitudinal wave. Now remember, longitudinal wave could be things like sound waves. Those are the most common ones you're going to see that we're really going to look at. But here is a longitudinal wave. I don't know why. There it goes. And what you'll notice, it's a little different. But they, instead of having a crest and a trough, they have what's called a compression and a rarefaction. And simply all that is, if you see all these little circles, those are little particles. So that's the matter itself. And look what happens as the energy moves from left to right. They kind of move from left to right as well, but they kind of bunch up. And where they bunch up is called the compression, right? They compress together. That's where the particles are close together. And then there's called the rarefaction, and those are those areas kind of in between the compressions, right? Where the particles are a little more stretched out and further away from each other. Now notice, remember, a transverse wave, the particles move up and down, but in the longitudinal wave, they move back and forth parallel to the direction of the wave. So here's the direction of the travel of the wave, direction of travel, right? Energy is moving from left to right, and the particles are bobbing back and forth. So notice they're bobbing back and forth. even though they might look like they're actually going to end up at the end, notice where my mouse is, right? It doesn't move. It's not going any further than this little initial area. It just kind of bobs back and forth, and that's what a longitudinal wave does. So the particles move parallel to the direction of the motion of the wave. All right, some additional features of a wave that you're going to need to know. So here again, we're looking at a transverse wave, right? We know because it has this kind of roller coaster look to it, is we need to know about amplitude. And today we're just going to focus on the definitions of these terms. Now later we're going to kind of get into what does amplitude do? What happens when I increase or decrease amplitude and such? Does that affect this wave? And it does, and we're going to see how that might be affected. But today what you need to know is that amplitude is the height of a transverse wave. And so if you look here, I've got it listed. So here's the crest. Now amplitude doesn't go from the crest all the way to the trough. It goes from the crest down to this what they call the rest position, or this line here. And this line here is the position at which the wave is at rest. So if this is energy moving, if you imagine this energy to kind of reduce, the wave may not necessarily be as tall, and then eventually it'll slow down a little bit, and eventually it'll be flat, like a flat line. And when that happens, nothing's being transferred, it's at zero. Okay? The amplitude is from that crest to the center, or to that rest position, that little center line. And then there's wavelength. Wavelength is simply the distance from crest to crest, or from trough to trough. Okay, crest to crest, trough to trough. Uh, so that's all you need to know about that. Okay. Now, wavelength is measured. This is a Greek symbol for lambda. So they measured in hertz, and we'll talk a little bit about that too. Or they're talking about frequency, which is measured in hertz. But I'm gonna get a little too into frequency at the end of this video. I got a few more minutes left. All right. Here's an example of a wavelength in a longitudinal wave. So we kind of saw it. This is a transverse wave, and we saw the wavelength from crest to crest. Now here's a longitudinal wave, and they measure wavelength from compression to compression. So compression to compression is what you need to know. So that's how they would measure the wavelength of a longitudinal wave. So the last thing I'm going to ask you to look at this week, I know it's a lot of terms, but that's why I'm giving you some time, right, is called frequency. And this is the number of complete waves passing a point in a given amount of time. So let's turn on oscillate. So we have here is a transverse wave. So the number of complete waves passing a point in a given time. So here, remember, the wavelength is from crest to crest, or trough to trough, and if I can pause it, right? And here is trough to trough, right? That would be one wavelength. And crest, this would be, if you imagine this kept going, this would be the top of the crest. And then here, crest to crest, right? So this would be a wavelength right here. Frequency is the number of complete waves passing a given point. So if energy was traveling, and this was traveling in this direction from left to right, okay, and if I put like an imaginary line there, I could count the amount of times you would get one wavelength to go through that point in a given time, and that's frequency. And you can imagine if I increase the frequency, what do you think might happen to the speed of the wave? Well, let's find out, right? You can actually do it right down here. So it's measured in hertz. Okay, so if I increase the frequency, okay, look what's happening. So the speed of the wave increases. So the amount of wavelengths going through a given point increases. If I decrease it, it goes down almost to nothing, right? It's very little. So very few wavelengths go through a certain point at a given time. So that's all frequency is. It's the number of complete waves. And we can do this for pulse too as well. I mean, through longitudinal. So here's kind of an example of a longitudinal wave. And we can measure as well. We can measure frequency through that too as well. Okay, so I just wanted to kind of point out those terms to you. And I would encourage you to come in here and play with this and see what happens, right? You can actually take out the loose ends. You could play with the amplitude a little bit, see what happens to the wave when we do the amplitude. There's all kinds of stuff. You can do manual, which you move it up and down. So I want you to play with it. Send me an email if you have any questions. check my module Canvas for instructions on how to do this next project. And I hope you guys have a great week. Thanks.